A shadow is the dark space behind an opaque object where the light is blocked by the object. When an opaque object is placed in the path of light, it stops the light from passing through. Since the light travels in straight line and cannot bend around the opaque object, it cannot light up the space behind it. Let's move to the activity. Now, one by one, hold each of the opaque object in the sunlight, slightly above the ground. What do you see on the ground? You know that the dark patch formed by each on the ground is due to its shadow. Sometimes you can identify the object by looking at its shadows. Spread a sheet of paper on the ground. Hold a familiar opaque object at some height so that its shadow is formed on the sheet of paper on the ground. Ask one of your friends to draw the outline of the shadow while you are holding the object. Draw outlines of the shadow of other object in a similar way. Now, ask some other friends to identify the object from these outlines of shadows. How many objects are they able to identify correctly? Some of the shadows of an object they may identify correctly and some are not. Right? Do you observe your shadow in the dark room or at night when there is no light? No. Do you observe a shadow when there is just a source of light and nothing else in a room? Yes. It seems we need a source of light and an opaque object to see a shadow. Let's see the another activity. Take a torch and a large sheet of cardboard with you. Hold the torch close to the ground and shine it upwards so that its light falls on your friend's face. You know, have a source of light that is falling on an opaque object. If there were no trees, buildings, or any other object behind your friend, would you see the shadow of your friend's head? No. But it doesn't mean that there is no shadow. After all, the light from the torch is not able to pass through his body to the other side. Now, ask another friend to hold the cardboard sheet behind your friend. Is the shadow now seen on the cardboard sheet? Yes. Thus, the shadow can be seen only on a screen. The ground, walls of the room, a building, or other such surfaces act as a screen for the shadows you observe in everyday life. Shadows gives us some information about shapes of objects. Sometimes shadows can also mislead us about the shape of the object. There are few shadows that we can create with our hands and make believe that they are the shadows of different animals. Now let's move to the activity 3. Place a chair in a school ground on a sunny day. What do you observe from the shadow of the chair? Here we see the long legs of the chair in shadow. Then, does the shadow give an accurate picture of the shape of the chair? No, it doesn't give the accurate picture of the shape of the chair because of the different position of the sun. Take a thin notebook and look at its shadow. Then take a rectangular box and look at its shadow. Do the two shadows seem to have a similar shape? No, it doesn't have a similar shape. Take flowers or other objects of the different colors and look at their shadows. A red rose and a yellow rose, for instance, do the shadows look different in color when the colors of the objects are different? No, because shadows has its own color. To the another concept, that is pinhole camera. There is an interesting pinhole camera in nature. When we pass under a tree covered with a large number of leaves, we notice small patches of sunlight under it. These circular images are pinhole images of the sun. The gaps between the leaves acts as the pinholes. Now, let's take two boxes of cardboard such that one can slide into another with no gap in between them. Cut Open one side of the each box. On the opposite face of the larger box, make a small hole in the middle, like a diagram A. Diagram A is the larger box and diagram B is the smaller box. In the smaller box, cut out from the middle a square with a side of about 5 to 6 cm. Cover this open square in the box with tracing paper or translucent screen. Slide the smaller box inside the larger one with the hole in such a way that the side with the tracing paper is inside. See the diagram C. Your pinhole camera is ready for use. Holding the pinhole camera, look through the open face of the smaller box. You should use a piece of black cloth to cover your head and the pinhole camera. Now, try to look at some distant objects like a tree or a building through the pinhole camera. Make sure that the objects you wish to look at your pinhole camera are in bright sunshine. Move the smaller box forward or backward till you get a picture on the tracing paper pasted at the other end. Now, look through your pinhole camera at the vehicles and people moving on the road in bright sunlight. Do the picture seen in the camera show the colors of the object on the other side? Are the images erect or upside down? Let us now image the sun with our pinhole camera. We need a slightly different setup for this. We just need a large sheet of cardboard with a small pinhole in the camera. Hold the sheet up in the sun and let its shadow fall on a clear area. The image which you see in the pinhole camera is more colored and the image is inverted. Now, let us see our sun with our pinhole camera. We need a slightly different setup for this. We just need a large sheet of cardboard with a small pinhole in the middle. Hold the sheet up in the sun and let its shadow fall on a clear area. Do you see a small circular image of the sun in the middle of the shadow of the cardboard sheet? Look at these pinhole images of a sun. When an eclipse is visible for your location, adjust your pinhole and screen to get a clear image before the eclipse is to occur. Look at the image as the eclipse begins. You will notice a part of the image of the sun gradually becoming the darker as the eclipse starts. Never ever look directly at the sun. That could be extremely harmful for your eyes. Now, let us move to the another activity. Use a piece of a paper or a long rubber tube. Light a candle and fix it on a table at one end of the room. Now, standing at the another end of the room, look at the candle through the pipe, like a diagram A. Is the candle visible? Yes, in a diagram A, the candle is visible. Now, bend the pipe a little while you are looking at the candle, like a diagram B. Is the candle visible now? Turn the pipe a little to your right or left. Can you see the candle now? No. What do you conclude from this? This suggests that light travels along a straight line. That is why when opaque object obstruct it, a shadows form.